Okay guys, so that last one was pretty involved, so I would like to try another one, and I'm going to show you how to use your graphing calculator. First step when we do this is we want to figure out where our asymptotes are going to be moved. Okay, asymptotes are affected by our horizontal and our vertical translation. Okay, remember that your vertical asymptote is the equation with x. So for your vertical, always look by x. And here we see that our x has a -3. I pull the opposite out of there. That means I'm going to move in the positive direction 3 spaces on the x-axis. So 1, 2, 3. So when x is 3, that's my new asymptote. Now let's do the y. If that's our x, our y asymptote is at the end there. So I'm going to move my function up 2, so my y asymptote is going to be y plus 2. Don't be fooled by the fact that the y asymptote is horizontal. Just think, it's a line that goes through the y-axis. That's why the equation for that asymptote is y equals 2. And the equation for this one, x equals 3. Now I actually want you guys to go ahead and refer to your graphing calculator. Okay? Using this will save a lot of time. It'll help you set up that XY table. Okay? So we're going to go to our y equals screen, and we're going to type in that function. Now that's a fraction, so make sure you start with a big set of parentheses because we want to keep fractions together. So we're going to go 1 divided by, now I want to divide that 1 by x minus 3. So that has to go in another set of parentheses. And then I close off my fraction with that other set of parentheses. And then I add plus 2. I hit graph. And you can see my hyperbola shape. I might even move the graph over a little bit just to really clearly see. You can change that with your window. You can make your x's, well, we can just do a standard window because this was not standard. Remember, standard window goes from -10 to 10. We hit graph, and there's my hyperbola. You can see the asymptotes. They show up right up there. Okay? So we go to second table. Let's try and get some points. And we don't want to pick real difficult points. Okay, I see some really good ones. Look at x equals 3. We decided that was our asymptote already, and it says error. Okay, so let's put some of these. These are really nice points to put up there. We have when x is 2, y is 1. So we'll go back over here and plot those points. According to our graphing calculator, when x is 2, y is 1. When x is 2.5, you get 0. 3 is an asymptote. 3.5, you get 4. 4, you get 3. I'm pulling these right off of the chart. You have to be careful because you have 2 branches of your graph. So make sure that your points give you both branches. Okay? So we're going to go to x is 2, y is 1. 2.5 and 0. 3.5 and 4. It looks like we're in luck here. It's going to give us both points. And 4 and 3. So it only gave us 2 points for our hyperbola, but that's fine. You can get the general shape from there. And again, the domain and range are going to be all real numbers except for the asymptotes. Domain deals with x's, so we say all real numbers except when x is 3. Range deals with y's, so all real numbers except when y is 2. And that's it. Okay, now you're going to see a rational function that looks like this, with ax plus b over cx plus c, so 2 different linear equations over one another. Honestly, guys, the graphing portion is exactly the same. You're still going to plot your asymptotes first. The way that you find those asymptotes is different, and this is how you do it. Okay, so when you have a function like this, if you want to find the vertical asymptote, that deals with your x, right? Remember, vertical for asymptotes deals with your x. You're going to focus on the bottom here, focus on x. When this denominator equals 0, the point that it equals 0, that's where you have an asymptote, because you cannot divide by a 0. So in order to find your vertical asymptote, you can do it this way, x equals negative d over c, and just use those numbers there, or set your denominator equal to 0 and solve for x. That'll tell you your vertical asymptote. Your horizontal asymptote, you're just going to take the coefficients of your two powers here. Here we have x's. We're going to divide those two coefficients, and you have your vertical or your horizontal asymptote. Okay? Now let's say we wanted to graph this function. We have 2x plus 1 divided by x plus 3. I'm first going to plot those asymptotes. To find my horizontal, again, I take the two coefficients of x there. Oh, there isn't 1 in front of x. That means there's a 1. That's that hidden 1. Okay, so I'm dividing 2 divided by 1, my two coefficients of the matching exponents, and you get 2. Okay? For my vertical asymptote, that is the point where my denominator equals 0. Okay? Remember, horizontal deals with y, so this asymptote is y equals 2. My vertical is when x is a value. So I'm just going to set my denominator equal to 0 and solve. X equals 3. So I'm going to plot those two asymptotes. When y is 2, I have an asymptote. And when x is 3, I have another asymptote. Okay? Your branches are going to go in the same positions here and here. To get those accurate points, you guys would follow the same procedure for entering it into your calculator and giving me an XY table. You would be expected to show me an XY table when you graph this, just so that it's accurate. Okay, so that's officially the end of 8.2. We will do practice with this in class. It would be an excellent idea for you to try a few problems just to see if you got it.